I'm going to be building a minimum spanning tree from an undirected graph using Kruskal's algorithm. So here is our undirected graph, or bidirectional graph. And then Kruskal's algorithm starts with a whole bunch of clusters, actually as many clusters as there are vertices. So here we have 8 vertices, so we have 8 clusters, and each cluster just contains one vertex. So how the algorithm works is it contains it has some sort of maybe like a priority queue of all the different edges in the graph, and the edges are considered from the smallest weight up until the largest weight. So the first edge to be considered is 2, because it's the smallest edge. And the process basically of considering an edge or not considering an edge is whether the edge connects vertices in 2 separate clusters. So here we can see that these two, V7 was in one cluster and V8 is in another cluster. So this is a good edge. We keep this edge. We merge those 2 clusters or 2 trees together from this edge 2. And we do this again. We look at the next highest edge, next heaviest edge, which is 4, between V6 and V5. And again, it's connecting these 2 were in 2 separate clusters, so we keep this edge. Again, we do the same for V3 and V4. And here we have 2 edges that have the same weighting, 8. So I don't think it matters too much. You can just pull either or in. So I've pulled the top one in. And the next weighting is another 8 again. So the next highest would have been 10, but because 10 is connecting 2 vertices that are in the same cluster, this edge is discarded. So 10 becomes a dotted line. So it's not going to be used in our minimum spanning tree. So we then look at the next 10 is down bottom left, and it connects, these are 2 separate, the V7 and V8 is one cluster, V6 and V5 is another cluster, so we merge these clusters via this edge that has a weighting of 10. And then again, you can see the top edge between V7 and V6 with a weighting of 12 becomes a dotted line. It's discarded by the algorithm because it would be joining 2 clusters that are already, 2 vertices that are already in the same cluster. And the next, again, we have 16 and 16 as our 2 weightings, so pick either or. And then the other, so here I pick the bottom one, the top one again would be connecting 2 vertices from the same cluster. So here we have our finished minimum spanning tree.